virus days, keeping the kids away. On my way to where the place is closed. Can you tell me how to get to Pittsburgh Street? Six feet away until everything's a-okay. Empty desks where we used to meet. Can you tell me how to get to Pittsburgh Street? It's a very lonely ride. Everyone is stuck inside to mask people like you. Mask people like what ridiculous virus days, keeping the kids away. Social distance where we used to meet. Can you tell me how to get to Pittsburgh Street? How to get to Pittsburgh Street? How to get to Pittsburgh Street?
Where's Emily? Elma, where's Oscar? Oh no! That's grouchy old Oscar.
Put the top of my trash can, little.
So 7th grade today, we're continuing to work on our equations. Again, equations are any problems that have an equal. Our goal continues to be to get the variable alone. I'm going to continue to want you to show the work the way I was yesterday, the way you will tonight, to emphasize our three main points, which are, since the equation is like a scale, we want to do the same thing on both sides to keep it balanced, that we always want to do the opposite, and that we're going to be able to check our answer by putting it into the problem. Today's difference is when a number is next to a variable, that means these are multiplying. So our job to do the opposite will be to divide. Later in the process, when you see the fraction bar, that means to divide. Our job will become to multiply. For multiplying and dividing, it's worth recapping the positive-negative rules up front. If you have two positives, that will always make a positive. If you have two negatives, it will also always make a positive. If the signs are the same, we'll get a positive. The only way you'll get a negative answer today is if there's one of each type, one negative and one positive. So here, let's find the variable. It's multiplying 2, so I'm going to divide. The way we'll show dividing today is going to be with the fraction bar. This symbol is on its way out in your life. Using the division box is going to be also on its way out in your life. The fraction bar is going to be in. So 2 is multiplying, so I'm going to divide by 2's. That will eliminate these 2's. Always the variable will be alone and equals will be around. And we'll have math to do. Dividing there will get us 7. And we can check that. 2 times 7 is 14. So check. Variable here is with the 3, so when we divide, it'll be using 3's to cross out 3's, because the goal is for the variable to end up alone. And everything got crossed out except for the variable on the left of the equals. Doing the math here, it's negative because they're different, 7. Checking that, multiplying 3 and negative 7 is negative 21. Here, when we divide, it's not just going to be with the 4, it's going to be a negative 4. The negative and the 4 are stuck together like glue. So to eliminate a negative 4, we can only do that with another negative 4. And over here, we need a third negative 4 before we do our solution line. Those eliminate to leave x alone and equal negative, because they're different, 5. Multiplying to check, negative times negative is positive, 4 times 5 is 20. If you think you have the hang of that already, you can try a column and then see if you end up doing what I do. There are going to be 2 trickier ones though in the column coming up. Here, again, we'll continue to divide using -3 to eliminate -3's. Over here, we'll need another -3. Make sure everywhere you wrote a 3, you wrote a negative, because that's how it was at the beginning, that's how it shall be. X is alone, positive when the signs are the same, and that'll be a 6. -3 times 6 is -18, and we're good. Here, we would divide by 5's to eliminate 5's. For 5 to go into 17, here's one of the ones I said would be mildly tricky here in this column. For us to do that division of 5 into 17, it goes 3. 3 times 5 is 15, but there's a remainder of 2. The easiest way to handle that is to just bring the big old 3, because it went in 3 times. The remainder due on top of a fraction, the 5 that was originally on the bottom, just copy it there. And I'll cut you a break today. Anything that comes out as a fraction, you don't have to check it. If this were a quiz or test, you could do 5 times 3 2/5. But you'd have to remember how to do that. 5 would go over 1. Mixed numbers have to be made impropers. Bottom times the whole number adds the top to get 17 fifths. Canceling 5's would give you 17. That is checkable, but any answer with a fraction, I won't make you do that. But if this were a test or quiz, you might want to do that just to preserve your own grade. For this next one, we would divide, but not just with 4's, with -4's. Since this had a -4, we need to get -4's all around the world here. Those -4's eliminate. Variable is alone. If you do the division of 4 into 22, 4 into 22 goes 5. 5 times 4 is 20. Remainder of 2. You could put that 2 on top of the original 4, but you always want to reduce fractions if possible. And this will end up being 5.5. And it's negative, since there was one of each type, that's a negative answer. Since it's a fraction-y kind of answer, I won't make you check that one. If you think you have the hang of it, you can try the next group. The next group is going to have another trick to it on one of them though. Here I'm going to divide by 6's. Draw my solution line. Cancel the 6's. X equals 5 trying to divide by 6. If this were in person, we'd end up with a little bit of conversation and controversy probably over this. But sooner or later, somebody would eventually suggest, just leave it the way it looks. 5/6 is okay. That's a proper fraction. We couldn't leave 17 over 5 because that was improper. But 5 over 6, fine. I won't make you check that either because it's a fraction. Anything with a fraction, I don't care if you check it. So this, we look to divide by 10's to eliminate the 10's and get the variable alone. 6/10 can reduce to be 3/5. So we will continue to reduce when we can. 3/5 is a good answer. It's negative because those were different. And when you have 3/5 and it's negative, there's actually 3 ways you could write that all look a little different but mean the same thing. You could either do the negative on the top with the 3, or you could do the negative on the bottom with the 5, or you could just throw the negative in front of the whole fraction so it isn't really with anything, it's just out there. Any of these 3 options is equally good, just pick one you like. Here we're again looking to divide, but not with 12's. I switched the order for the first time. The x is now on the right, and the number with the x is the one that we want to eliminate. So 7 is who needs to divide on both sides to get the variable alone. It's a negative answer because they're different types of numbers. 7 into 12 goes once. Remainder would be 5, and leave the 7 on the bottom. Don't have to check it because of the fraction again. Here we divide, but not with 15s because we're focused on the variable, and not just with 3s because the 3 has a negative with it. So it's -3 all around the world to eliminate -3s. Variable alone, dividing here is -5, not a fraction, so check it. -3 times -5 is +15, that checks. Continuing to divide with 7s, because that's with the variable and wants to be eliminated. Variable equals, this is a proper fraction, just leave that alone. Continuing to divide with -6s, eliminating -6s to get the variable alone. Negative with negative is a positive. 6 into 20 goes 3, and we'll get a remainder kind of fraction. The remainder would have been 2. 2 over 6 is better to be a third. Don't check it because it's a fraction. Then when we cross this line, we have a change of pace. Now, problems are dividing, so our job is going to be to multiply. This X symbol for multiply is not going to happen anymore for us because it looks like a variable and we have enough variables in these problems already. So what we're going to do to show multiplying is use the dot. So if this is dividing 2, I'm going to use the dot to show that I am multiplying 2. That eliminates the 2's. Variable equals 14, which is checkable. 14 dividing 2 is 7. Check. Again, here I'll continue to multiply with -3's. Not just 3's, but -3's. Since it divided a -3, you have to multiply a -3. The negative and the 3 is a package deal here. Those get eliminated. Negative times negative is positive, and that is 12, which we can check. 12 dividing -3 is -4. If you think you got that, try 2, and then you can unpause and see. With the variable on the right dividing, I'm going to multiply with 6's because it's all about the variable's number getting used. So that's going to multiply 6. Variable alone gets us a -30, which we can check. -30 dividing 6 is -5. And then our last one for multiplying would be multiplying by 8's. Since 8 was with the variable, that's our multiply number. Variable alone, it is -24. In terms of work shown, again, emphasis would be, if my problem is dividing, make sure you use the dot to show me multiply. If I am showing you multiply, make sure you use the fraction bar to show me divides. Draw those solution lines. There's always a variable and an equals. There's always a pair of numbers on the variable side getting crossed out, be eliminated, and then you'll have math to do. And if the answer is a whole number, I forgot to check one here, -24 dividing 8, that's -3. I am going to check that. You should see a lot of little check marks all over your papers. If yesterday you weren't showing it that way, go back to yesterday and try again, because I'm not going to give credit for the papers unless I'm seeing check marks on whole number answers. I'm seeing cross outs of numbers on the variable sides. I'm seeing the same thing happening on both sides, because that's what I'm trying to emphasize here is this thought process of opposites, same to both sides, because that's what you're going to need to do well here in the future. So if you don't understand, send me an email, we'll work it out. See ya.